So a couple of housekeeping factors. We have disabled the audience microphone and video, but it'd be welcome to comments and questions in the chat window. The session is being recorded and will be made available after, so you will receive CPD certification from CIBSE also. And for the agenda, so I'll introduce the speakers and the topic, and then a panel discussion will be held after the presentations. The speakers will each give a 10-minute presentation. This will be followed by an audience prompted panel discussion, which will be chaired by Bryony Turner. So do drop your questions in the chat window. So just some initial scene setting today. Net zero refers to a state in which the greenhouse gases going into the atmosphere are balanced by removal out of the atmosphere. The COP26 goals included secure global net zero by mid-century and keep 1.5 degrees within reach. By the end of 2019, only 67 countries had announced net zero or carbon neutrality pledges. Now, according to the Net Zero Tracker, 134 of 198 countries have stepped up. However, the pledges are only the start of the journey towards net zero. Countries and cities need to connect long-term and short-term climate mitigation targets and activities. These ambitious goals must be broken down into specific actions. So today we'll hear how this is being done in areas of critical infrastructure for cities, energy, healthcare, and data centres. We'll hear firstly the strategic and infrastructure focused perspective, and then from those working at the building scale. So in order of appearance today, we have Ben Kuchta, who's the Group Resilience Improvement Manager at the National Grid. We have Stephen De Souza, who's the Strategic Programme Energy Manager at Greater London Authority. We have James Outram, who's Associate Engineer working at Atkins Global Engineering. And we have Kate McCormack, who's the Energy Manager at Great Ormond Street Hospital. And Kate's been researching into the links between smart technology and asset and energy management. So without further ado, I'll hand over to Ben from the National Grid, who's doing his presentation on powering on innovation in energy in pursuit of net zero.
Thank you, Kirsten. So good morning and afternoon. My name is Ben Kuchta. I'm the Group Resilience Improvement Manager for National Grid, and I'm responsible for the Organisational Resilience Strategic Programme. So to that end, I've got to focus on climate adaptation and the energy transition, which is why the title of my presentation is all about innovation in energy. So I've got about 10 minutes to cover this rather broad topic, but I want to start by explaining that National Grid really is at the heart of transforming the energy system in the UK and in the US. Our businesses supply gas and electricity to millions of customers and communities, and we've got quite the focus on driving change through engineering innovation and through the incubation of new ideas. So thank you for moving on to the next slide. On this particular slide, you'll see that we've both developed and continue to work on a number of projects and initiatives to help us understand climate risk at both a national and regional level. What you can see to the left of your screen right now is a snippet taken from our climate change risk tool, and that helps us to understand the impact of climate change on our assets in towns, cities and villages. The information that we pull from this tool actually helps to inform things like our asset management strategies, and our UK electricity distribution business is also working on a project called Accelerated, and that looks to establish a methodology that considers the projected impact of climate change on their network forecasting activities. So we're very proactive in that space. And just to highlight the impact that that has had, if I were to look, or as I look to our electricity transmission business, again in the UK, they have significantly increased the robustness of their climate adaptation assessment. And that's alongside the Met Office UK CP18 climate model. So In essence, they have reviewed their potential climate risks over a period of nearly 35 years. And over that 35 years, a total of 86 potential risks were identified. So with this information, we can clearly see that there are a lot of potential impacts. So for every new asset that we build, we consider all of this information to ensure that resilience is built in from day one. And additionally, it helps us to think about the controls or the mitigation that we may use should a risk that's attributed to an existing asset or assets escalate. So as an example of the type of risk escalation that we're seeing, you'll see in the bottom right hand side of this slide that we're expecting 30 UK substations to move into a high risk flooding zone by 2040. And so it's important that we work with stakeholders such as the Environmental Agency and the local resilience forums to plan ahead. So if we can move to the next slide, please. Thank you. I do want to shine a light on our US business, as I spoke quite a lot there about our UK businesses. So in terms of what we're doing regionally across the states that we operate within in the US, our vision here is to fully eliminate fossil fuels from both our gas and electric systems, so enabling all homes and businesses that we serve to meet their heating needs without the use of any fossil fuels by 2050, if not sooner. And a popular topic of conversation is our gas networks. We'll be replacing all of our gas we'll be replacing all of our gas networks over in the US with renewable natural gas and green hydrogen. And we're focusing quite a lot on making it more affordable and more reliable to over 20 million people across New York and Massachusetts. We're also working to collectively come together to achieve emissions reductions across multiple sectors of the economy, so electricity, transportation, building heat and industry. So reducing emissions from the building sector, which I'm sure the rest of the presenters will touch on throughout the course of today, it's probably one of the most important and challenging problems that needs to be solved to achieve net zero. And heat is absolutely essential. So keeping it affordable and reliable is critical for things like economic development and well-being. And just very quickly, we've split this fossil-free vision into 4 pillars of action. So we've got energy efficiency in buildings, 100% fossil-free gas network. Third pillar is all about hybrid electric gas heating systems, and the fourth is targeted electrification and networked geothermal. And of course, we're doing all of this whilst maintaining resilience, reliability, and safety, just to name a very few important factors. If we could go to the next slide, please. Thank you so much. So coming back to the UK and thinking about future demand, we ultimately have an electricity network that was designed to connect and transport energy from coal, nuclear, and gas, and we're expecting 60% of all of the offshore wind developments to bring their energy onshore around the East Coast. So we definitely need to transform the network for a different low carbon future. So in essence, we're looking to connect over 44 gigawatts of offshore wind in what's been described as the engine room of the UK's green and resilient future economy. And the infrastructure that's associated with offshore wind, it'll enable all communities, villages and cities to the data centres and the hospitals within them to tackle climate change at a very local level. So the rollout of electric vehicle charging stations and reducing carbon emissions from home heating, they're just 2 of the changes to green energy that will be supported by offshore wind over in the UK. Now, another important factor to all of this is that we're also looking to both maximise the use of our current assets and build new capacity. So on the left of this slide, you'll see that we're very much interested in and looking at things like dynamic ratings, demand flexibility, to innovation in conductors. And to achieve this future, we're working very quickly with developers, suppliers, environmental groups, local communities to find the best local and environmental solutions to enable us to deliver energy to the UK population. We could go to the next slide, please. Thank you. So there are some more UK-based engineering challenges that I just very quickly want to touch on too. So on the right hand of this slide, you'll see that in this particular scenario, we've modelled the distribution of excess demand and generation for each snapshot year in hours. And as the years go on, we'll see this initial increase in excess generation. And so it's important that we look into things like network stability and system restoration. And again, just very quickly, it's here that I really want to point out that the journey to a resilient net zero future, in essence, requires us to really get into the first principles or nuts and bolts of what we do. If we could go to the next slide, please. Thank you. So just to sort of round things off, our business, it certainly relies on strong relationships with absolutely all of our stakeholders to make it happen. There's our customers who depend on us to connect them to energy, our suppliers who have great complementary experience, skills and resources. There's national and regional governments, local communities and consumers of the energy that we transport. And of course, there's the economic regulators, as well as the government agencies responsible for health, safety and environmental standards. So from an adaptation perspective, it's going to be a combination of our engineering ability combined with stakeholder engagement that really will enable us to meet these green transition targets and avoid any maladaptation. And that really helps, or is helped by innovation as well, as I mentioned on the first or second slide. And what I want to end on is that the challenges that we face aren't trivial, and I really do hope that what I've presented to you today gives you a high-level insight into some of the strategic climate and resilience related matters that we're dealing with at both an international and regional level. Thank you.
Brilliant. Thank you very much, Ben. That was really insightful. Really picking up on the importance of planning and the challenges which will come about with the transformation from fossil fuel heat. And I'm sure really those are just the tip of the iceberg of all the really great work that you're doing there. So this leads us on to Stephen D'Souza from the GLA, who will discuss the challenges of increased electrification with the Mayor's commitment to reach net zero by 2030. Oh, Stephen, you're on mute.
That's
great.
That's not a great start. Thank you. My name's Stephen D'Souza. I'm from the Greater London Authority, and I work within our energy and environment team. So, I mean, I'd like to talk about some of the challenges coming from the Mayor's target for getting to net zero for London by 2030, and it flows quite nicely from the last presentation when you were sort of hearing about the sort of national challenges of net zero, and then this is looking in more detail to a more granular level at the challenges for you know, what is the UK's largest city and accounts, you know, for a lot of its electricity, energy demand and population and economic activity. So the Mayor's committed to London being net zero by 2030, and earlier this year we published some analysis on how that might be achieved and the implications. Now it's documents available on our website, and you know, it's a large Word document, nearly 100 pages. I'm just going to give you a bit of a flavour what's in there, you know, particularly focusing on the challenges for electrification. So the way the analysis was done was looking at 4 different pathways of achieving net zero, and you know, if you like, four different scenarios. You can see those represented on the left of this slide. So there's high electrification, high hydrogen, and then a no constraint. So, you know, sort of doing everything, and, you know, not worrying about cost, and doing things like not just replacing fossil fuel boilers with low carbon heat sources or renewable heat sources, but also actually scrapping fossil fuel boilers. So a much more you know, radical scenario. So the one that the mayor has picked as his preferred scenario is in between, which we called an accelerated green scenario, but you know, it is still very challenging. And you'll see on the right the effect of the different scenarios on carbon emissions going forward. You see that by 2050 they all get to roughly the same place, but obviously the you know, the more radical scenarios have a steeper slope, and you know, particularly focusing on that 2030 target. So you know, none of these scenarios get to absolute zero carbon by 2030. It is net zero rather than absolute zero. So there would be a cost of offsetting residual emissions, and also, you know, there are obviously large costs in actually in getting to any of these scenarios, and also you know, these the investment required will generate a lot of jobs for London, which is obviously of particular interest at the moment, you know, sort of coming out of COVID, and also looking towards sort of green jobs of the future. The next couple of slides, I'm just going to give you a bit more of a flavour of what these scenarios involve. So this is giving you an idea of some of the numbers. I mean, Ben referred to the big transformation that's required in the heat sector and the way that we heat our homes and other buildings. So you'll see that in that accelerated green scenario, the one that the mayor's preferred, that there would be just over 2 million heat pumps by 2030. There would also be nearly 500,000 connections to heat networks. You know, there will be a big shift from fossil fuel vehicles to electric vehicles, but even with that, and I think it's something that people often miss, that there will need to be a reduction in the number of passenger miles. So you see a 27% reduction there. So that's you know, just shifting the fuel source to electric isn't enough. It requires behaviour change as well. The other thing I just draw your attention to on this slide is that that top row, that there is a big need for energy efficiency, and that's actually something that's in common across all the scenarios. So we haven't played with different levels of energy efficiency. There's a high level of energy efficiency across all scenarios, and that has a very important effect on the amount of electrification that's required. Obviously, if you don't have that energy efficiency and you have a shift to electrification, you need even higher levels of electricity and the infrastructure to get it to where it's needed. So this is a similar slide, but talking to the sorts of policies that are needed. So again, you know, talking about the transformation on the heat sector, you would need a ban on replacement boilers from the middle of this decade, from 2026. And as I mentioned earlier, you don't need scrappage of gas boilers or cars, so you can replace them at the end of their lifetime with a low zero carbon alternative. But if you wanted to move faster, then you would need to get into scrappage. So just briefly, the impacts on the electricity network, you'll see that, not surprisingly, peak demand increases to 2050, though there is a bit of a dip to 2030 just because of that increased level of energy efficiency. And you'll also see that the number of substations, which is a sort of measure of how much upgrading of the network, the electricity network, the electricity distribution network is needed. You'll see that goes that obviously goes up over the next few decades. And that's quite a challenge, particularly in London, because the vast majority, I think it's 97% of the network is underground because of the dense sort of residential and other use of buildings nature of London. So I think better start wrapping up. So I've just got 2 slides on next steps. So this analysis was published a few months ago. It's there on our website, and we're keen to make sure that people are aware of it and discuss it with stakeholders. So any feedback welcome. We're starting to use this to inform our own planning of what we're doing. We're also doing work to support organisations who want to move towards net zero, and I've linked there to the low carbon accelerators, which are a range of programs which give technical support to organisations who either want to improve their energy efficiency or want to get into low carbon heating or other local energy projects. And then finally, as I've said, this does have implications for the electricity distribution networks. So we at the GLA are working closely with the distribution network operators and with Ofgem to ensure that the networks are ready to invest in what's required for net zero. We're also keen to promote the use of flexibility, so that it's not just about investment in sort of new wires and new substations, but also making better use of the existing network by being able to shift when electricity is used, or make better use of generation storage in conjunction with demand of electricity. And we're also working with a number of boroughs on local area energy planning, which is seen as very much the way of trying to make these sort of things work better in the future. And we're keen to find out what's the best scale to do this local area energy planning. So we're looking both at level of boroughs, at a number of boroughs together, and also within boroughs. And I don't think there's a right answer to this, but you need to plan at different levels. So thank you, and I'll hand over to the next speaker.
Brilliant. Thank you, Stephen. Again, really interesting presentation there, and linking back into Ben's, highlighting the need also for significant flexibility in the network and the importance of the energy modelling. So what we'll do now is hand over to James at Atkins, who will look at data centres, which consume huge amounts of energy. They're a hugely growing market with huge reliance. both within cities as well as more rural areas.
Perfect introduction, Kirsten, and thank you for that. So I'm one of the lead engineers within our mission critical sector, and whilst that covers lots of different buildings and facilities, over the next few slides I'm just going to focus on specifically around data centers. So what is a data center? In its most basic form, a data center is a series of computers, or we call them servers in the trade, as you can see on the image on the right hand side, but much wider than this. They're the very foundation of our modern world. Without them, simply society would cease to function. Data is every part of our lives, from buying a pint of milk to keeping your healthcare records secure, and everyone has a carbon footprint. And I mention this because data centers consume a huge amount of power and can also consume a huge amount of water. So let's look at that in a bit more detail. When we talk about power, typically data centers are between 10 and 20 megawatts, and we're just completing a facility that's 40 megawatts in the UK. And just to put that in perspective, and this is a great stat that kind of blows my mind every time, is each megawatt is enough to power up to 1,000 homes a year. That's 1 megawatt. So you can kind of start to get an understanding of those numbers. And in case you are wondering, the 20% there actually equates to about 5.5% of the world's carbon emissions. So a really big sector to go after, and some big wins around reducing our carbon emissions. So when we look at resilience at building level, we look at trying to define this in tiers. So broadly speaking, when you're moving from a tier that has from a lower tier to a higher tier, you have more infrastructure, and that achieves a greater level of resilience. So as you move from tier 1 up to tier 4, you can see on the left hand side there, you get duplicate systems. You have to have more raw materials put into the building, which again increases your capital and operational costs. So just to reiterate that you've got two, when we talk about resilience for data centers, they consist of the two main systems that come in. So your incoming power and then your water. So when we've got big cooling systems, some of them use water to help with that. So although data centers by their very nature are mass users of electricity, have huge amounts of rare materials, and have effectively having our industrial sized coolers, all of this can be successfully counterbalanced. So the main way that we do this within the sector at the moment through buildings is strategic development through carbon neutrality, so carbon offsetting. We reduce energy either through limiting it or using renewable sources. You can look at your technology side of things, so improving and adopting innovative cooling solutions, and then actually you then start to look at the buildings themselves and try to improve their efficiency and how they work. And I'm just going to quote two examples. The industry giants like the likes of Amazon, Apple and Google that we've all heard about announced that their data center operations are going to be carbon free by 2030. So if we just think about carbon free and that terminology, my second example to this is perhaps a lesser known provider outside the circle of data centers, and that's Virtus. So Virtus currently use 100% of their electricity, and that's committed to net zero by 2030. So that's net zero, so perhaps a slightly lesser standard compared to your gold standard of carbon free. So where are we on the journey? The performance gap. There was this fantastic survey completed by Schneider Electric, who have great reach into all of these data centers. By the very nature of the data center, they've got they're very well monitored, they're metered, and they've got access to all of that data electronically. So, you know, what they found was actually out of all of their operatives, actually, there's a bit of a way to go from getting that data, getting our you know, carbon reduction, energy efficiency, bringing that all together, and then actually planning how we get to that net zero target. And at this point, I'm going to say that there is a standard methodology within our sector that looks at power usage effectiveness, right? Okay, so this is very similar to your white goods, your A to G white goods. It gives your, in effect, your data center and energy rating, which is really, really important. The downside to this is there's quite a lot of inconsistency across the sector, from building to building and facility, and also there's no arbiter. Unlike building regulations, there's no one there policing these changes and this requirement. So although there's methodology, I think we need to go further with it. Where do I see this changing in the future? Well, water in particular is a key issue. So the global demand for fresh water is expected to exceed availability by 2030. So each data center that uses water for its cooling is going to need to move away from that because of that requirement. And just in case you're wondering, that 8 million gallons there is equivalent to 12 Olympic-sized swimming pools. So a huge amount of water, and just remember that for that 1 megawatt, that 1,000 homes for a year. So huge amount of energy. So where does this push us? I see that the technology needs to improve. So our computers or our servers, they need to be able to withstand greater temperatures and changes in humidity within the environment. So that's really important. We're going to need Ben's 44 gigawatts of offshore power, providing a greener grid. That's really important. And then really one that we've sort of just touched on was about, you know, we generate a huge amount of heat, but there's, what are we doing with that heat? So can we look to reuse it through heat networks? And we've just touched on that. So heat networks are something, especially if you've got a data center next door, is something that we should look to use. And that brings me to my closing slide. And I just want to leave you with a couple of points. And I said that we were sort of completing a very large data center earlier. Now, I think, you know, what's the future? What does that look like? I think we're going to see more smaller or edge type data centers. So ideally, these are applications which really suit cities such as London, where land is at a premium. I think by linking these smaller data centers together, you have this swarming, so you can actually have a more resilient infrastructure. And you're actually more able to link these data centers together to allow you to take some offline, so you can then start to match your load profile to your requirements. So actually that helps drive up the energy efficiency. And then where's this all going? Well, there are 30 billion internet connected devices in the world today. That's only ever going to increase. So we need to do that with technology. We need to advance that technology in a sustainable way, and we need to do that together, really. Thank you.
That was great. Brilliant. Thank you so much, James. So yeah, some really, really important points there. And not only do we have a challenge here with the consumption of power, but it's water usage too. We're seeing more and more water shortage around the world, even in the UK. London experienced heat waves with warnings from the CEO of the Environment Agency that within 25 years, the southeast of England could run out of water, which is quite a scary thought. So yeah, there's lots to think about, obviously, just beyond the power for data centres and the whole water element around that also. So thank you. So what we'll do now is we'll move on to another very important example, which is critical infrastructure within hospitals and the challenges being faced here. So Kate, I will hand over to you.
Thank you. I'm new to the NHS. I only joined November last year, so it's been a very big learning curve for me, both in terms of how hospitals operate, but also how the staff engage in the operation of the data centres. One thing to notice is we have a very clear and direct correlation between healthcare and the impacts of climate change. We see more people with breathing difficulties. We see more people suffering from adverse impacts of temperatures. In 2019, about 900 excess deaths were caused due to the heat wave. But at the same time, as well as recognising all of that, we're a major contributor to the problem. So the Lancet called us the climate change, the biggest global health threat of the 21st century. And we can't ignore the fact that the big hospitals like ours have a major carbon impact footprint. But the one thing I've been impressed with is just how engaged all the staff are actually at ground level. So we have anaesthesiologists, nurses, the IT guys, all coming together to say, how do we do this? And really engaging in some of the initiatives, which is fabulous, but it's a big challenge. Looking at how we fit in with the bigger picture, the net zero targets, obviously we all know. Within the NHS, we want to go further and faster. So we're looking to reduce 80% of our direct emissions by 2032, with net zero by 2045. And for indirect emissions, it will be down by 80% 2039 and 2045 for wider emissions. So our direct emissions are a bit perhaps different to a lot of people. They include things like medical gases and aesthetic gases, our fleet, our ambulances, all of those come into our direct emissions. But also we have a lot of emissions from things like medical equipment and medical gases that we need to account for. To date, we have reduced by 62% in our direct emissions since over 2019. That was by 2020, and about 26% on our NHS Footprint Plus. So a lot of good work done on the direct emissions, a bit more to do on the wider emissions. When we look at the age of the estates, we do have quite an old estate. So despite the announcement of 40 new hospitals, that's going to be a drop in the ocean compared to the rest of the estate, which is huge and complex. So as you can see, over 12% of our hospitals predate 1948. We also, tied into that, we have quite a backlog in maintenance. So there's about £9 billion worth of backlog maintenance within the existing estates. So there are some big numbers for the NHS on what we need to achieve. We have 80% of our energy, building energy, is still from gas. And while it's a very small amount, less than 1%, we actually still have hospitals using coal. We've got 192 CHP units across the secondary estate, including 2 at Gosh. And while they produce cost-effective electricity and heat, they are a big problem in how do we move away from fossil fuels. The NHS at the moment have a 4-step approach, very sensible. Firstly, energy efficiency. There is still a lot of work to do in this area. It's something I'm looking at ourselves. How can we use technology, particularly our building optimization and O&M systems? How can we use technology to reduce our demand for energy? We've also looking at how we prepare the estate in the future to move away from fossil fueled heating. So particularly building fabric and preparing for a move over to air source heat pumps, ground source heat pumps and the like. So switching away from fossil fuel heating into, as I say, electrical heating, it's going to be a big challenge for us, both financially. we're looking at about 1.3 billion to convert to electric heating. But there's also then the challenges, how do we do that within an existing building where we have to continue to provide services to our customers? There's a lot of savings to be made, but likewise a lot of investment needed. So about 5 billion across those 4 areas. Financially, can we do it? Well, yes, 37 billion was committed to test and trace, and this is just as big a health emergency as COVID was. But it's not just about finance, it's also about the people. So do we have enough skills within the NHS and within the wider industry to support developing our net zero plans and to make sure that we can achieve our commitments? We all know that it is challenging to get the right people on board at the moment with the right skill sets to be able to deliver. So we've got a lot of considerations within the NHS. Some are unique to us, some are unique to common across all areas. Climate change, of course, the increased temperature and requirements for water. Going back to our existing estate, it's estimated that about 90% of the hospitals that we have now have some issues with overheating in summer. Indeed, some hospital wards are hitting 30 degrees at an ambient temperature of 22. So on the surface, we need additional cooling, but we also need to look at other ways of reducing our heat loads so that we can reduce our demands whilst continuing to work in a climate that's warming. Obviously, the impact of heat is amplified in city centres, and increasing flood risk and water demands are also going to be an issue for us. As I mentioned, the adverse impact on health of climate change, that's also going to increase costs to the NHS. So everything is being done at the moment in an field of increasing costs from all different directions. How we decarbonise heat in the NHS is the one challenge that I'm still very much scratching my head on. How do I move away from CHPs when that could put my energy bill up if I switch one off by over £1 million? How do I retrofit? Where do I get my heat from? How do I get my electricity? It's also a bit of a disconnect with all the targets on when things are coming online. So I've seen some great presentations on heat networks, which are fabulous. They're not going to help with our 2030 targets. How do we get our security of supply? If we did a wholesale switch over to air source heat pumps, do we have enough electricity in the grid to be able to support that? It's a question mark and not something I've been able to find a definitive answer for just yet. But we also, being a hospital, we need a level of resilience. So at the moment, we have a number of different heat sources, fuel sources coming onto site, and we can switch about as needed. If we decommission the CHPs, again, we're then reliant 100% on the grid, or we have to increase our generator capacity. Retrofit of existing buildings, as I say, that's going to be a really big challenge. When I've looked at how do we net zero the NHS, there's a lot of focus on new building. How do you orientate your building? How do you install renewables? If you're in a city centre and you have a footprint and that footprint does not change, then we need a few more answers to those questions. Funding, particularly given energy prices and expenditure, there's a limited pot of money. So every penny we spend on an energy saving measure is great for the long term. But right now we have a budget problem with the current energy prices. Now, there is some good news coming along. There are a lot of things happening at a slightly higher level than myself, and a lot of announcements that we're expecting soon on how we can resource and how we can deliver some of these targets. But at the moment, the challenge to the NHS is going to be huge.
Super, thank you so much, Kate. That was, I think, really touched on and brought together all the issues we'd heard right from the work going on at the sort of national grid level and the city level in terms of particularly electricity, energy supply and resilience of that, right through to when you hear about the complexity at the building level of the kind of dependencies and what you're having to juggle in terms of reducing sort of the carbon emission side of things, but also thinking I still got to keep the hospital running, and it's really, really critical, and how do you do that without compromising carbon emissions? What I think we'll do, we have got a few specific questions towards the presentation, so I'll just ask a few of those. One of I think each speaker, and then I'll ask the panel whilst I'm asking the specific technical questions. I've got this question in general of, do you think enough is being done to support security of supply and resilience in the face of a changing climate, particularly with regard to resilience and dependency of buildings on energy infrastructure? So from your expertise level, and also perhaps having the insights now of both sides of the coin, as it were, during this session. Kate, I'll just start with the question that's come up from you for your presentation, first of all. So Ali has asked, is 37 million enough to tackle this large project?
Sorry, that 37 billion, that was test and trace. For what we're looking to do, they've estimated 5 billion. I think that's an underestimate by quite a way. But we've also got £9 billion of backlog maintenance to do. So the overall level of investment needed in the NHS infrastructure is going to be substantial. So
thank you for that sort of realistic answer, and it's in the face of difficult time for public expenditure, but this is part of the challenge when you're starting, and this is why CIBSE Resilient Cities Group really likes to look at and ask these questions around existing stock, because you've got backlogs of operational maintenance for business as usual, never mind sort of bringing this kind of improvements to buildings in. Okay, then I'll ask Stephen next. Laden, and apologies to our audience members if I'm pronouncing your names wrong. So with the plan that you outlined, Stephen, he asked, would this plan work with recession on horizon? I guess you didn't sort of touch on that. So have you been looking at the sort of recession versions of the plan? Do you stress test it for that?
Well, I mean, as I say, this this investment would create jobs. So I think when very much looking at the sort of coming out of the pandemic, is sort of very much framed in terms of green recovery. So yes, there might well be a recession on the horizon, but there will be a need for investment. I mean, I'd also make the point, that if the present national government hadn't gutted sort of residential building energy efficiency programs, about a decade ago, then a lot of people's bills would be a lot lower. So, it would have been a much more effective use of public funds to actually invest in energy efficiency than just to give people a few £100s off their bills, as it's doing now. Now, that's kind of happened, so it's perhaps that can't be reversed. But I hope that that the current government, which still hasn't delivered on the promises in its manifesto on the amount of money that would be invested in energy efficiency, I hope the current government will not make that mistake again.
Thank you for that answer. There's some very good points made there. And I'd add, if we've known about climate change for a long time and had the data with the Met Office scenarios, we could have also been stress testing the design of the energy retrofit for hotter summers as well as the winter weather. We'd be in a much better resilient place now, but it's never too late to start. And then lastly, a technical question. James, there were several that came through from Nikki, so please do look in the chat and respond. But the upvoted one for your presentation said, we're looking at projects where data centres use direct immersion, more data in smaller spaces and much higher heat source for big heat pumps. Is the direct immersion not an option?
Lots of options. So just to put a little bit of context around that is how do you pack more computers or servers into a smaller footprint and therefore get a higher cooling density or higher IT load that you require? So yes, there are lots of different options, especially around the cooling. I think, you know, that's I think in terms of technology, I think there's always going to be a cooling solution. I think where you get to, actually, perversely, is the power side. So you can and you know provide that high density cooling requirement, but it's actually in the end will be the power and how you deliver that power to the computers and servers. And I just say that that just condensing your data center doesn't necessarily help, and the technology to do it isn't readily available. So although that is, you know, where we can head, and there are plenty of facilities out there, these computers have to be specially made. There's no, you know, in terms of replacing them, there's a big capital uplift to do that. So I think you know, you'll see the technology as with all technology, right, as it all becomes more frequent and easier to get hold of and easier to manufacture, then actually I think you'll see the trend move towards that anyway.
Super, thank you, James. That was really helpful. And then Ben, there were no direct technical questions, so I'll go over to you to leave a very appropriate, especially given the last answer to my more general question to panelists. It's what the City Resilient Cities Group sort of like to do, to give a space to do, is to think about this connection between the works and the efforts to mitigate climate change, but in a way that improves climate resilience and perhaps adaptation. So my question to the panelists, just as a reminder, was, do you think enough is being done to support security of supply and resilience in the face of a changing climate, particularly with regard of resilience and dependency of buildings on energy infrastructure? So Ben, having had the insight from the building perspective as well in this session, do let us know what thoughts you'd like to share.
Certainly. So my experience over the last sort of 12 months is that it's certainly been ramped up on a lot of people's agenda, and we're starting to have very valuable conversations about the topic, and it's becoming less linear, I find, which is really positive. So we're taking into consideration numerous circumstances that sort of amalgamate to create a situation or a scenario, and we're starting to sort of look into the detail of how the cost of living and security of supply and renewables and net zero targets all come together, and what we need to do to be able to sort of deliver that through various different circumstances. So, you know, we've touched on things like a recession being on the horizon. So we would look to, you know, talk about that and model those sorts of plans and those scenarios around a topic like recession. So, and we from what I've seen that's really exciting is that the technology is really starting to get really quite good. I've seen models, algorithms, innovation projects compute huge sums of data, and you know, there's the application of category mathematics and all this weird and wonderful stuff that really fills me with confidence that we're making the right decisions, because we're able to model and stress test the business through these various things. So in essence, yes, I think right now we're doing the right thing. We're on the right track. We need to keep the momentum going, and we need to be very positive with all of this and press on.
Thank you for that, Ben. And for those of you not aware, some of the climate modelling is brought into the evidence base from the Environmental Change Institute, Oxford, for the National Infrastructure Commission. So I know that the climate modelling is brought into that for critical infrastructure. Would any of our other panelists like to kind of respond on that main point, and then I will pick up a few questions that have just come through in the meeting chat. Oh, there's complete silence. It's a really difficult one, isn't it? I mean, Kate actually really illustrated the complexity of dealing with that at a building level, at the NHS level, and then James talking about it's not just the energy resilience, it's the water, the water and the concerns around water scarcity, and then the interconnections between energy and water, because you often need water pumped in order to even access it for cooling. In that case, I will turn straight to just a couple of questions we've just had come up, and then I'll wrap the session up as we are coming towards the end. So John Green has said that significant energy savings can be achieved by ensuring BMS control systems are properly commissioned and maintained. It is estimated that this could produce a 5 to 10% energy saving. I guess I might tweak on to his question. You know, there's a data footprint also to these systems. So do you have a kind of perspective on that, and even on the maybe the realistic energy saving that can be made when you're doing it in practice, so rather than modelled? Maybe Kate, do you want to start with that, and then maybe James?
Yeah, our BMS system is quite old and needs a substantial amount of work and recommissioning and to reset various bits and pieces, which is my first big challenge. But our BMS system alone, I think, has got something like 100,000 points on it. So even that is a huge job of working out what we need and how it should work. I suspect our energy savings will actually be much higher than the 5 to 10%, because if you go back historically, people said hospitals are 24/7. Well, of course, they're not. Areas of hospitals are, but the hospital isn't itself. So we really need to do a lot more work setting back areas that are not used out of hours. Theatre setbacks is a big project we're working on at the moment to understand what we should be doing. And of course, energy data is the key to a lot of this. And at the moment, I simply don't have it. So there's still the basics and fundamentals to do: increased metering, better BMS systems. A lot of time and effort needs to go into those, and the savings will be great. And then I'm hoping by the time I've done that, I'll have a few more answers to the bigger picture heat decarbonisation.
Which is a classic example, I think, if I may say it, even if you're not able to, but picking up on Derek Clements-Croom point about, you know, why has there been a build-up of backlog of maintenance costs? Well, there's failure to invest in the maintenance and operational sort of investment that's needed. That isn't a new technology necessarily, that is day-to-day maintenance, or those budgets are stolen from. It's because you suddenly have to do more on fire risk or something like that. So this just really goes to prove the point that if you've got good, you don't rob the maintenance budgets, and perhaps rob them in sometimes for the land value as well on sort of new development. You know, you really need to look very carefully about what's being forecast in for the maintenance budgets, because when you come along to these kind of problems and challenges, you really need to be able to start off from that invested in starting point. So I'll just hand over to James, and then I think we'll get to a last point from each speaker before we close.
Perfect. I was going to say, by contrast, in the data environment world, these facilities are really heavily monitored. When you walk into one of the control rooms, it looks like the Starship Enterprise, right? You've got monitors all over the wall. They know exactly how much cooling they're putting into the facility at any one time. It's live data that's being fed back, and it's because we design against those tiers that I mentioned earlier about resilience. So, you know, they cannot have those facilities drop out. Right, so that's the bottom line. So they've got to monitor everything continuously. So is there scope to reduce energy? They are always monitoring where that energy is being used. So I think maybe in the controls element, it's there. What we need to do with that is use that data that we've got intelligently, is to make better informed decisions around what are the next steps. So actually, how do you get your data center that is running well to a place of net zero? and those are the bits that I mentioned earlier. It's funny, in the chat, Kate, John said we could help with that, so I'll just
and then Ben and Stephen, if you'd like to add any just last reflections, and then I will close the event.
Yeah, I mean, perhaps, just to mention a sort of couple of things. I mean, been talking about building management systems, which I guess is being thought of in a sort of context of commercial buildings. I mean, we were recently involved in a sort of pilot project looking at domestic residences who had hot water, electrically heated hot water. And in that sort of case, we found that there was a lot of potential by, managing the time at which the hot water is heated to actually, produce better outcomes for the residents. I mean, in most cases, not in every case, but in most cases, these people will be fuel poor. So, it's possible to actually save them money, and it will be possible to save them more money in the future as the electricity markets change and give better rewards for taking consuming electricity at a time when it's cheap, i.e. kind of overnight when there's too much electricity on the system where it's hard to get the financial reward for that. I mean, the other point I just wanted to make, we've heard from James about data centres. One of the things we're looking at is actually a project where the waste heat from a data centre can be used to heat some new build and possibly even a hospital nearby. This is in a part of West London. So and I think that sort of emphasises a point I was making towards the end of my presentation about how a lot of this stuff has to happen at quite a local level, that traditionally the electricity system, and not criticism of National Grid, but the electricity system is very kind of top down, but actually particularly at the distribution level, a lot of these changes need quite detailed planning at local level, so that you can kind of coordinate quite difficult things between people who've got too much heat, people who need heat, and the sort of new companies that need to come along to transport the heat between these places. So it's all quite difficult and challenging, but I think it's all possible. Thanks.
Thank you. Some really pertinent points there, and then appropriate then to ask Ben for your last reflections.
Certainly. So I suppose what I want to end on is that I'm a really big believer in increasing business intelligence, like the situational awareness piece, so that we can really model or understand the impact of our plans and that of others, right? So I have made consideration towards specific areas of the network based on the information that I've got to hand, and that can be it can be considered quite a closed view. But when I start to include other information from other stakeholders, partners, regulators, customers, that sort of understanding really grows. So I understand what impact I have and they have on sort of this journey towards net zero. And that really provides a sense of confidence. So we've got to, I think the two main things are, let's continue to work together and really look to build that suite of innovative tools that help us grow that business intelligence and that situational awareness, so that we deliver confidently and we can make it happen.
And that's a great note to close this session on. And I think we mentioned earlier when we were giving the context of the session, the net zero tracker, 239 of 1,177 cities have pledged net zero targets. So that's still really small at a city level. And what you've heard here today is some examples of the complexity in the UK of taking the kind of national top-down approach and the efforts of our grid and the way we operate and have our energy system at the moment structured in the UK, and what's going on at the city level and then the building level within the cities. And it's so complex. And part of what Resilient Cities Group does is offer a platform for those working internationally on this, not just at the building services level, but all the professions that are interrelated. So architects, other types of engineers, planners, those working on planning energy infrastructure, all types of people. We really welcome you to our group to continue having these discussions and also sharing best practice and what's not worked sometimes is really important to share too internationally. So if you've enjoyed today's seminar as part of London Climate Action Week, please do consider joining the CIBSE Resilient Cities group. I'm sure in a moment we can pop in the chat our page. Please do look out for our future webinars. I'm Bryony Turner, I'm Vice Chair of the CIBSE Resilient Cities Group, and you heard earlier from Kirsten Johansson, our Chair, so we thank you very much for joining us today. Sorry we slightly overrun, but we did want a chance to ask some of your questions, and any questions you popped into the chat that haven't been answered, we will ask our speakers just to pop in the answers and we'll make that available in a blog on the CIBSE Resilient Cities page alongside. This event has been recorded, so you should be able to catch up if there's any of the discussion you wanted to go back and see more detail. So thank you very much, and sorry we're a little late closing, and a huge thank you to our speakers because we set them some quite challenging questions for their talks and challenging timeframes. So thank you all.